In this lesson, we are going to talk about the intercept form and writing equations for quadratic equations. The intercept form of a quadratic function it looks like this, and we have already seen the vertex form and we've seen the standard form. And so now what we're going to talk about is we're going to talk about the intercept form. So, as you know, sometimes the letters are, kind of weird, but they actually are standard. And so in this type of a situation, the P and the Q, those are going to be our intercepts, or in other words, our zeros, or our solutions to the quadratic equation. We know from other situations that A is telling us about the reflection and the stretch or compression. So that's kind of an introduction to that situation. Okay, so for example, if we see an equation that says f of x equals 3 times x minus 4 times x minus 1, we know from the intercept form that 4 and 1 are zeros. Remember, insiders lie. So we would say that the solutions are 4 and 1. Or in other words, if I was to graph it, the quadratic is going to go through the x-axis at 1 and at 4. And so we know it's going to look something like that. Okay, so we have an idea about it anyway. Okay, we also know how to write this in a different form, and we do that by multiplying everything together. So we're going to first just put that together. So we'll have the 3, and then x squared minus 4x minus 1x plus 4, and then we would simplify. And now we're going to distribute. And so this is just another way to write the same thing. So all of those equations say the same thing. It's just a matter of how do we want it. Okay, now we also know from standard form what we see here, that the y-intercept is 12. We know about the stretch being 3, so actually we could draw a pretty good sketch knowing what we know. We know the intercepts are 1 and 4. We know the y-intercept is at 12, and so if there's a difference right here of 1, so if we go 1 over that way, that's going to also be at 12. So we could actually draw a pretty good sketch without even knowing what the vertex was and have a pretty good idea of what that looks like. Okay, now remember that the axis of symmetry is located halfway between the zeros, or in other words at the vertex. So the vertex is going to be there's symmetry for the parabola, and so wherever that axis of symmetry is, it's going to be halfway between the two zeros wherever it crosses the x-axis. And so if we wanted to know where the axis of symmetry is, or in other words where our x-coordinate for our vertex is, we can just find the average, or the midway point, the midpoint of our two zeros. So in this situation, since I know my zeros are 1 and 4, I could say 1 plus 4 divided by 2 is equal to 5 halves, or equal to 2.5. So here again, when I go to make my graph, I've got my intercepts at 1 and at 4, my y-intercept at 12, this other one here at 12. I know that at 2.5, and then I could find the vertex pretty easy by plugging in 2.5 into my equation that I had. Okay, so I could plug in 2.5 right there, and I could come up with what the vertex was. So there's a lot of ways to look at our equations and have them be useful to us. Okay, so let's look at a couple examples. Number 1, determine the axis of symmetry for the function. So in other words, we want the coordinate of the vertex, the x-coordinate. Then we're going to determine the equation of the quadratic in standard form, so our answer has to be in standard form, but I'm going to give you the two zeros. Okay, so I know that my two zeros are x equals 2 and x equals negative 2. So I'm going to use those 2 points to start my equation. So I'm going to write x minus 2, okay, that takes care of that. Remember, insiders lie, times x plus 2. Now we know from prior experience that we're going to have an a there, we just don't know what it is, and that's going to equal y. So that's step 1. Okay, then we're going to take this point that it goes through. Don't worry about the fact that if you notice that that's the y-intercept, don't worry about that. We can't really use that the way it is anyway. So what we're going to do in the second step is we're going to replace those points. So 3, that's my y. X is 0. And so what I've got is I've got 3 is equal to a times negative 2 times positive 2. So I've got negative 4a is equal to 3, and so a is equal to negative 3/4. So now that I know that a is equal to negative 3/4, I can write my new equation. Y is equal to negative 3/4 times x minus 2 times x plus 2. Now, if the directions said to just write it in intercept form, I would be finished. But the directions said to write it in standard form, so I'm going to have to go ahead and multiply all this out. So I'm going to take care of this part of it first. That's going to be x squared plus 2x minus 2x, and then minus 4. If you notice, that's a difference of squares right there. Then I'm going to multiply that by negative 3/4. So my equation in standard form will be negative 3/4 x squared plus 3. And that's the answer. Notice how right here I've got the 3, and notice how that matches. That's the y-intercept. So I know that that at least looks right. So you also might want to check your graph just to kind of practice doing this. So if you've got zeros at positive 2 and negative 2, and you've got an intercept of 0, 3, that's halfway between. So that actually should be the vertex as well if you did this right. And so we've got other ways to check and see if that's the right vertex. And so you know that it's opening upside down. It's going to have a max because of that negative. So everything looks like it fits together. Okay, let's go to number 2. In this problem, we're going to identify the x and y intercepts, the axis of symmetry, and the vertex of the function. And I'm just remembering that in the last question, we forgot to say what the axis of symmetry is. The axis of symmetry is going to be x equals, and that's going to be 0 because that's where my axis of symmetry goes through that vertex. Okay, so anyway, back to this one. So the x and y intercepts, the axis of symmetry, and the vertex of the function. So given this equation. So first of all, the x-intercepts, because of the format that it's in, the x-intercepts are really easy. So the x-intercepts are going to be negative 5, 0, and negative 2, 0. Now to find the y-intercept, I'm going to have to put this together, like multiply it all together so I can find the y-intercept. So I'm going to go ahead and FOIL that. So I'm going to have x squared plus 2x plus 5x plus 10. And so that's x squared plus 7x plus 10. Okay, so that is going to tell me my y-intercept. So my y-intercept is 0, 10. All right, now the axis of symmetry. For the axis of symmetry, I'm going to need to find the vertex. And so I know, I shouldn't have erased that. I know that, I keep erasing the wrong thing. Sorry, let me write this again. X squared plus 7x plus 10. So I know that my vertex is negative b over 2a, and so that's going to be my axis of symmetry. So x equals negative 7 halves because that's the x coordinate. So now to find the vertex, I know that it's negative 7 halves, and then I just have to plug in negative 7 halves right there for x and right there for x to find out what it's equal to. So in this situation, I think I'm going to use decimals. I don't normally do that, but negative 3.5 plus 5, and then negative 3.5 plus 2, that's going to give me 1.5 times negative 1.5, and that's going to be negative 2.25, and that's going to be my vertex. And so I've done everything that I was supposed to do using my equations. Okay, the next thing that we're going to do is sketch the graph. So I'm going to take all of that information and I'm going to actually just rewrite it here so that I know what it is I'm looking at. And just with a few points of information, we're able to draw a really good graph. So the first thing I need to do is get an xy axis. Since my y-intercept is 10, I'm going to probably need to scale this. So I think that I'm going to draw my x-axis right here, my y-axis, and then I think that each one of these is going to have to be 2. So 2, 4, 6, 8, 10 of necessity so that I can have them show up. So I'm going to have my y-intercept here at 10, and then my x-intercepts will be at negative 5. I can have this still be 1 and 2. So 1, 2, 3, 4, 5, and at negative 2. Okay, now you see that this y-intercept is obviously not the vertex. Okay, my vertex I know has to be in between. And so this negative 3.5, that actually looks right on. Okay, it looks like this is going to be my axis of symmetry. Negative 3.5 and then negative, remember this is negative 2, and so it's just going to be right past here. That's going to be my vertex about right there. And so when I draw this, remember the symmetry, and that's going to be really helpful. So this point right here is going to be symmetric with something over here. So since I know that this is 2 away, if I go 2 away, so to negative 7, and then I go up to 10, that's going to help me have a really good graph. So when I go to sketch my graph, it's going to be about like that. Okay, let's go to number 3. Determine the equation of a quadratic that has a minimum, so that's my vertex, at negative 4, negative 8, and it passes through this point. So I'm going to write my equation. So since it's giving me the vertex, that sounds like I need vertex form. So I'm going to go back to what we've done before with vertex form. Y is equal to, I don't know A, x minus negative 4, so that's plus 4, quantity squared minus 8. This is vertex form because they give me the vertex. Now because I have a point that it's going to go through, that's how I'm going to find A. So I'm going to substitute negative 5 equals negative 2 times x plus 4, quantity squared minus 8. Negative 5 is equal to negative 2, and then this is going to be x squared plus 8x plus 16, and then the minus 8. Now I'm going to combine some things. Negative 2x squared minus 16x minus 32 minus 8. So negative 5 is equal to negative 2x squared minus 16x minus 40. I'm going to add 5 to both sides. So I'm running out of room. Negative 2x squared minus 16x minus 35. And that is going to be my equation in standard form. And I can, graph it and make sure that it has everything it's supposed to have. If I was going to just check something like this, a graphing calculator would be a good thing to use, but we can use some of the other things that we've learned before to check it also. Okay, and I'm just realizing that I totally screwed this whole thing up, so I apologize. Let's try this again. I don't want to erase the whole video, so let's try this again. I'm sorry, we're going to do y equals. I had everything right up until I substituted things in, so hopefully you caught it and were saying, hey, Mrs. Bench, you screwed up. So let's substitute this in. My mistake was I put negative 2 in for A, and I didn't know A. This is what it should be. Okay, so negative 5 is equal to, this is going to give me 2 squared is 4, so I'm going to have 4A minus 8. I'm going to add 8 to both sides. And then A is equal to 3/4. Okay, that is more reasonable. Okay, now I'm ready to write my actual equation. So it says write it in standard form. I'm going to first write it in vertex form, and then I'll get there. So 3/4 times x squared plus, here's my 8x plus 16 minus 8. 3/4 of 8 is 6. 3/4 of 16 is 12. And so I'm running out of space. I'm going to erase some stuff. Okay, so 3/4 x squared plus 6x plus 4. Okay, that is my equation that is going to represent this graph. Okay, I feel much better about that. That sounds much better. Okay, now the next question is a story problem. And so it says that Beth is shooting a potato from a potato launcher. The launcher is 4 feet high. So if we were to draw a diagram of that, so we've got Beth. Okay, that's Beth. And she's shooting this potato. Okay, so what goes up must come down. So it's looking like we expect. When she shoots the potato, she sees that the potato hits a bird that is flying 6 feet away from her and 35 feet high. So let's think about what that means. 6 feet away from her is this direction, and 35 feet high is this direction. So if she's at the origin, then the bird, or the point on the graph, is 635. So our equation is going to go through the point 635. I know that her starting height was 4 feet high, and so that's my y-intercept. Okay, so we're trying to find what is the initial velocity, and so we're going to use that formula about the gravity and everything. So since we're talking about p, it's going to be negative 16 t squared. I don't know the initial velocity, so that's what I'm going to solve for. Times t plus the initial height is 4, and that's equal to my h of t. Now the height at a particular point in time, okay, so the point that it's going to fit into is this 635. So I'm going to say negative 16 times 6 squared plus the initial velocity times 6 plus 4 is equal to 35. And so I'm going to find out what point is this happening. So I'm going to do some calculations with my calculator and get this. So I'm going to get negative 576 plus 6 times the velocity plus 4 is equal to 35. And then I'm going to have 6 times the velocity. When I simplify everything, I'm going to get equals 607. And so the velocity is equal to about 102. It's 101.7. And so we could say approximately 102. Okay. And so that's hopefully makes sense, but you're just plugging in numbers to find the missing parts of the equation. Okay, now a couple of questions at the end that I want you to explore with your calculator, and these would be like a bonus type question. If we take this equation, this is the equation of a circle, if you remember that. And so what I wanted to do here is practice putting some things in your calculator. So this is the equation for a circle with a center at 0, 0, and a radius equal to the square root of 20, or 2 square root 5. And so what we're going to do is we're going to see how to put this into our graphing calculator and see what it looks like there. So if you'll get your graphing calculator, the first thing we need to do though is on paper we need to solve it for y. And the problem with the graphing calculators is you have to put it in terms of y. You can't put it in terms of y squared. So we can't just say, well, y squared equals 20 minus x squared. We have to actually solve for y. So I'm going to have to take the square root of both sides. And when I write this, I actually always put my x first, so I'll have negative x squared plus 20. And so that's what I'm going to put in there. So remember that when we took the square root, we have to put plus or minus. So I've solved for y. So now let's go and put it in our graphing calculator and see what happens. So the first thing that I want to do is check your window. So if you'll go to window, which is this button right here, check your window and make it look like this. You might want to pause the video and make sure your window looks like that. Then you're going to go to your y equals menu. And in your y equals menu, you're going to type in the two different equations, because you see right here we actually have two different equations. We have positive square root of negative x plus 20, and then we have negative square root of negative x plus 20. Okay, so we're going to have to enter both of those. So in our calculator, in the y equals menu, you're going to put both of these in. So we're going to put in y1 and y2. So make sure you use the negative sign and not the minus sign. And so you want to pause this video, make sure you put it in that way. And then we're going to graph and see what happens. So when you graph this, the thing is, even though we know it's a circle, it doesn't really look so much like a circle. That's because of the pixels and because of the compression of the window and things like that. But if you count, you are having your center at 0, 0, and you count, you know, where you're at and everything's good. Okay. And actually, I'm wondering. Yeah. So anyway, everything's good. It's going to look kind of oval, and so just know that that's very normal. And if you look on your calculator, you should see better that it looks better. My picture is a little bit far away, so you can't see it as good, but that's going to look okay. Okay, let's try the next one. I want you to pause the video right now and try to solve this one for y, and then turn it back on, and you can see if you did it right. Okay, so you're going to have y squared is equal to negative x minus 1 quantity squared plus 100, because I took this and I put it on the other side of the equation. And now you just take the square root. So it's really not that hard, it's just, it looks really intimidating. We're going to have the square root of negative x minus 1 quantity squared plus 100. And so these are the two equations that you're going to put in, one with plus and one with minus, into your calculator. So get your calculator, and we're going to go back to the y equals menu, and you're going to type in the two equations. So pause the video, type in the two equations just like we've got here. Remember to use the negative instead of the minus, and then hit graph. Okay, once you hit graph, you'll notice that in this equation, the center of the circle we know was at 1, 0, and so it's a little bit, it's not at the origin anymore, it's scooted a little bit more. So we've got a radius of 10 that way and a radius of 10 that way. And you also notice you have a radius of 10 both directions. So everything looks good, even though it's a little bit squished. You'll also notice that you have this little gap right here, and I don't really have a good explanation of why that happens, but it does always happen. So we're really having the calculator do a system of equations, and there's kind of this gap in the middle here. That's completely normal. I don't know how to close that gap. I don't know that there is a way to do that. Okay, one last one. This one's a little bit harder. To solve this next one, we have to, on paper, do it first. So go ahead and pause and see what you can do, and then come back and watch. Okay, I'm going to first get the y part by itself. So I'm going to have y minus 4 quantity squared equals negative x plus 2 quantity squared. It probably would not help things to multiply that all out and get like x squared plus 4x plus 4. That's probably not helpful, although you could if you wanted to. Okay, then I'm going to take the square root of both sides because I have to get that square out of there. So I'm going to have y minus 4 is equal to plus or minus the square root of negative x plus 2 quantity squared plus 16. Then the last step is just to add the 4. So I'm going to have y is equal to 4 plus or minus the square root of negative x plus 2 squared plus 16. Now you could put the plus 4 at the end if you wanted to, and in my calculator that's actually how I did it. It doesn't matter. I would recommend on this one you change your window to the standard window of negative 10 to positive 10. And then last, enter it into your calculator. So you'll notice that I put the plus 16 part. Okay, hold on. It looks like, and I can't fix it now because I'm not with my computer, it looks like I forgot to put this plus 4 right there. I've got the 16, you have to put parentheses there and then plus 4. So put yours right and yours will look better. I wondered why mine looked a little bit funny, but I didn't investigate it. So pause this and then graph it, and let's make sure it looks right. So we know that our circle should have a center at negative 1, positive 4, and it should have a radius of 4. So I'm not even going to show you my picture because it's a little bit off anyway. So you know what that should look like. And remember, don't worry about the gaps, okay, but your circle is going to be a little bit up here, and it's going to look more like that.